This is the topic, or sorry, Unit 5 review packet, second part where we cover pages 3 and 4. For this, we're going to be using our knowledge of congruent triangles and Cpctc to solve for missing values. 23. Solve for x given that triangle ABC is congruent to triangle FGH. It probably should have said solve for x and y. We'll do both just because it's more fun that way. FG is the side that corresponds to x in this triangle. If we look at our congruent statement, FG are the first two letters, which means they correspond to AB. G corresponds to AB. Y is side GH in the second triangle. GH are the last two letters, which must correspond to the last two letters in the other one, BC. Corresponding parts of congruent triangles must be congruent, so that means x has to equal 10, and y must be 17. (24) Solve for x given that triangle ABD is congruent to triangle CDB. Now it seems pretty obvious that the 5x should probably be set equal to the 75 because those are the only numbers in this problem, but we'll double check just to be sure. X is angle B of triangle ABD. Its corresponding part would be D in the second triangle. Here's angle B from ABD, and D from the second triangle would be here. Those are corresponding parts, so to solve, we'll set them equal to each other. 5x equals 75, divide both sides by 5, and get x equals 17. Sorry, 15. 25. Solve for x and y given the triangle XYZ is congruent to triangle FED. X is on the side 3F, or sorry, EF in triangle DEF. EF are the first two letters. The first two letters over here are XY, so we know that EF and XY have to correspond. Y is in angle D, the second triangle. Angle D is the last letter, which means it has to correspond to Z in the other triangle. So we know those two parts have to go together as well. That gives me two equations to solve. 30 equals 2y. To get y by itself, divide by 2, and get 15. Here, 3x must equal 9. Divide by 3, and get x equals 3. 26. Solve for x given that triangle CBA is congruent to triangle DFE. In this triangle, the x is located in the angle labeled D. D is the first letter, its corresponding part must be C from the other triangle. 9x must equal 27. To get x by itself, divide by 9, and get x equals 3. Again. 27. Given triangle PQR is congruent to triangle XYZ, solve for x, y, and z. X is in angle Q of this triangle. Q is the second letter. Its corresponding part must be y. So we know that those go together. Z is in angle P. P is the first letter. Its corresponding part must be angle X from the second triangle. Finally, that means Z and R also have to be corresponding angles. To solve, it doesn't really matter what order we go in. I can set orange equal to orange, blue equal to blue, and yellow equal to yellow because those are the corresponding parts. So that gives us 15x equals 75. Orange to orange would give us z equals 20. And yellow to yellow, 5y equals 85. To solve for x, divide by 15. 75 divided by 15 would be 5. This doesn't need to be solved because z is already by itself. And finally, to get y by itself, divide by 5. 85 divided by 5 would be 17. 28. Solve for x, y, and z, given that triangle ABC is congruent to triangle FDE. I'll take the same approach for this one. AB are the first two letters. The first two letters in the second one are FD. So AB corresponds to FD. Next we have AC. AC are the first and last letters, which corresponds to FE. Which means that the third set of corresponding sides must be these two. Well, I can set blue equal to blue, yellow to yellow, and orange to orange. For blue to blue, that would give me the equation 3x minus 2 equals 13. To get x by itself, add 2. 3x equals 15, divide by 3, and that gives us 5. Again. Next, orange to orange. For my y's, 9y minus 5 equals 22. Add that 5 to both sides. Divide by 9. And get 3 for y. Finally, for my yellows, the z, 10z equals 25. To get z by itself, divide both sides by 10. 25 over 10 we can reduce by dividing by 5, and that would give me 5 over 2. The last part of Unit 5 is proofs involving congruent triangles and Cpctc. In general, every proof has the same element to it. The first thing you will always do in a proof, of course after stating the given, is try and show that the two triangles are congruent. In a Cpctc proof, we move on from there by showing that because the two triangles are congruent, it means the corresponding parts must be congruent. You can always tell if it's a regular triangle congruence proof or a Cpctc proof based on what it's asking you to prove. If this step is asking you to show triangles are congruent, it's just a regular triangle congruence proof. If it's asking you to show parts are congruent, like angle H is congruent to angle F, then you know it has to be a Cpctc proof. Our first statement is always going to be the given, so this would be BC is congruent to segment JK, DC is congruent to JI, angle D is congruent to angle I, reason given. The last statement always has to be what you're trying to prove, so triangle DBC is congruent to triangle IKJ. In this proof, we're given all the information we need to set up for a triangle congruence. All we need to do is mark up our diagram and figure out which one to use. The first part of the given says BC is congruent to JK. This is already marked in the picture. DC is congruent to JI. This is not marked. So we'll mark it. I used 1 because there was already 2 here. And the last one, D is congruent to I. This is a right angle. It wasn't in the given, but it is in the picture. If we didn't have this right angle here, I just covered that up, then the triangle congruence we would use would be ASS. However, ASS is not a thing, so we'll have to use the right angle. With the right angles in place, we can use ASS because that's the only time where it does work. In this case, we call it hypotenuse leg. So my reason, HL. Given BU is congruent to BC, angle UBA is congruent to angle CBA, and our prove statement, we're going to prove triangle UBA is congruent to triangle CBA. First thing we do is mark our picture up based on the information that was given to us. We have BU is congruent to BC. This is not marked. BU to BC. UBA is congruent to angle CBA. It's got to be these two angles. So now that we have our given marked, this gives us two pieces of information. We've got a side and we've got an angle. We need a third for triangle congruence. So we always look for our two obvious ones right away. Vertical angles or shared sides. This has a shared side in the middle that I can mark congruent. However, if I mark it here, I've got to state that over here. So this would be, in the top triangle, segment BA is congruent to. Now to make sure I get the parts in the correct order for the second segment, I'm going to cheat a little bit and look at my proof statement. BA are the last two letters of this triangle. The corresponding last two letters would also be BA, so the order is not changed. The thing that lets us say that things are congruent to themselves is the reflexive property. Finally, looking at our triangles, in this one I have SAS, and in the second one I also have SAS. The angle needs to be sandwiched between the sides, which it is. So my triangle congruence would be side, angle, side. 31. Given, segment HE is congruent to segment FE. Angle D is congruent to angle G. This is not asking me to show that the two triangles are congruent. It's asking me to show that the parts are congruent. That means this is going to be a Cpctc proof. Angle H is congruent to angle F, reason Cpctc. In order to use Cpctc, I need to show the triangles are congruent, just like I did in the last two proofs. So even though it ends differently, I'm still going to end up doing the same things. So first we'll look at our given statement and make sure it's marked. HE is congruent to FE, there's HE, there's FE. Angle D is congruent to angle G. Yep, got those two. In order to show triangles are congruent, I need three parts. Right now I have two. Of vertical angles and shared sides, these have vertical angles in the middle. So I'm going to mark those congruent and then state it over here. So this one was DEH is congruent to, and I started with D because it was the single marked, GEF. Makes it easier to line up the parts. And that is vertical angle there. Looking at my triangles, I have angle, angle, side, angle, angle, side. So my triangle congruence is going to be justified by AAS. In my congruent statement, since I've already got the letters in the correct order here, I'm just going to copy the same order for this. Triangle DEH is congruent to triangle GEF. Finally, number 32. Here, we don't have numbers for how many steps it's going to take us, so we'll just see how many it takes. We know the given has to go first. EQ is congruent to PQ. CE is parallel to PR. I know my last step will be EC is congruent to PR, and because I'm not showing triangles or congruence, I'm using parts. The justification will have to be Cpctc. And I'll just add the number for the step when I get done. Okay, so first let's make sure our diagram's marked. EQ is congruent to PQ, that is. CE is parallel to PR, that is not. So I'm going to mark CE and PR, but I'm also going to draw or highlight because I'm dealing with parallel lines. And anytime I have parallels, I always want to highlight. So now we move on and we look for our two obvious ones, vertical angles and shared sides. This does have a pair of vertical angles. So I'm going to mark my vertical angles congruent, and we'll make that the next step of our proof. So this one would be EQC is congruent to angle. I started with E because it was directly across the double marked side. Its corresponding part would be P. My reason, VAT. To show triangles are congruent, I need three parts. Right now I have two. I have an angle and a side. Now, these parallel lines probably mean I'm either going to be doing alternate interior or maybe corresponding. I need a transversal, and a transversal's got to be a part of both triangles. CR could work as a transversal because it is in both triangles. EP could also work as a transversal. You can use either one. If I choose EP as my transversal, I can mark these angles congruent because they're alternate interior. They're inside the parallel lines, but on opposite sides of the transversal. So I would say angle E is congruent to angle P by alternate interior angles theorem. If I wanted to, I could show that C and R were congruent by alternate interiors as well by using a different transversal. And if you do, you would get a slightly different conclusion to your proof. But since I have enough to show congruence, I'll just show congruence now. This triangle would be angle, side, angle. And in order to use ASA, the side has to be sandwiched between the two, which it is. And we have ASA in the second triangle. So my triangle congruence, triangle EQC, I'm just taking the same order that I used up here, is congruent to triangle PQR. My reasoning, ASA. In order to use Cpctc, I had to show the triangles were congruent. I did. So that means this has to be step 5.